Hello guys, so today we're going to be doing lesson 3 on your book. So everybody go ahead and go to page 536. The lesson name is a constant ratio and it's going to be talking about how geometric sequences are similar to exponential functions. Okay, so let's go ahead and get started. All right, number 1. Oops, sorry. All right, it says identify the constant ratio in each representation. So Ms. Jimenez went ahead and drew this for us, or wrote this down for us, which is really nice because it tells you how to find the constant ratio whenever they give you a table, a graph, and an equation. So whenever they give you a table, you're going to take the second value and divide it by the first value. So, and you have to make sure that the y values are right next to each other. So you have to do like this one, y1, and this has to be your y2. So if you do that, -6 divided by -2, that gives you +3. Okay, and to see if you did it right, whenever they give you an equation, it says the constant ratio is the value that has the exponent of x attached to it. So if you look here, that's the one. Okay, and you see we got the same thing. The constant ratio here is 3. So constant ratio is 3. And then whenever they give you a graph, you pick two y values again. You have to make sure they're right next to each other, like this one and this one. And you take the right one. So this would be my the right one, and then you divide it by the left one. Okay, and that should also give you 3. All right, next one. So for this one, again, I'm gonna pick it doesn't have to be the first two, it could be the last two as well. Like if I want to do 180 divided by 90. So this is my y1 and this is my y2, but you have to make sure that they're right next to each other. This will give me 2. And then if I look at my equation, it is 2, right? And if I wanted to pick 2 points, let's say this one and this one, I would do the right one divided by the left one. And that should also give me 2. So right here, the constant ratio is 2. All right, next one. So let's say I have y1, this is my y2. Again, I do 123.4 divided by 1,234. And that gives me 0.1. And look here, and yes, it does, right? So my constant ratio here is 0.1. And you could have also picked 2 points here. Let's say this one and this one. Remember, you have to do the right divided by the left. Okay? All right. This one, you're going to do on your own. So take a look at this page. You're going to be working this on the board. All right, next one. So I'm not sure what page this is. I don't think it says. No. So just go ahead and flip through a couple pages until you find where it says activity 3.4, writing exponential functions. So let's go ahead and get started. So it says the amazing Aloysius is practicing one of his tricks. As part of the trick, he cuts a rope into many pieces and then magically puts the pieces of rope back together. He begins the trick with a 10-foot rope and then cuts it in half. He takes one half of the halves and cuts the piece in half. So that's really important sentence right there. That's why she highlighted it. Make sure you highlight that. Then it says he keeps cutting the pieces in half until he is left with a piece so small that he can't cut it anymore. Complete the table to show the length of rope after each Aloysius cuts. Write each length as a whole number, mixed number, or fraction. Then graph the points on the table. Okay, so number of cuts, this is like my x, this is my y, right? So it says the first value is the original length of the rope. So number of cuts, 0. Whenever he didn't cut it at all, it was at 10 feet, right? That's what the sentence said. And then the next value is the original length divided by 2. Each value after that is number before it divided by 2, because every single time he's cutting it in half. And that's just based on what they told us in the sentence, right? So that's what she did here. She did 10 divided by 2, which is 5, and then 5 divided by 2, which is 2.25. So now we do 2.25 divided by 2. And let me get my calculator out real quick, which is 1.125. And then you do that and divide that by 2. And that should give you 5.5625. And then, oh, I'm losing my voice. And you do that one more time. Okay, so now we graph it. So whenever x was 0, y was at 10. So that's right here. Whenever x was at 1, y was at 5 right here. Whenever x was at 2, y was at 2.25. So right here. Where is it? Right here. And then at 3, it was at 1.125. 4, it was at like half. And then 5, it was like even smaller than that. So you can see right here, this is what an exponential function looks like, right? It has that form. Like if I were to connect these points, that's an exponential function, right? All right, so I just wanted to point that out real quick. Number 2, write the function LC to represent the length of the rope as a function of the cut number C. So she said y equals the original length, and then parentheses constant ratio to the power of x. So my original length here was 10, right? 10 feet. My constant ratio, let's see. I'm going to do 5 divided by 10, and that's 1/2. Because remember, you do y2 minus y1. So that's 1/2 right here to the power of x. So that's my equation. It says, the next one says, use your function to determine the length of the rope after a 7th cut. So the cut is your x, right? The number of cuts is your x. So we're going to plug in 7 for x. Put this in the calculator right here, just this part that I put a box around, and that's going to give you a number. So I'll let you guys do that part. All right, moving on. Write an exponential function of the form f of x equals a times b to the power of x for each table and graph. So this is the equation for exponential functions, okay? The a is your y-intercept. That's the starting point. The b is the constant ratio, just like how we did in page 536. So here, this is my y-intercept. Remember, y-intercept is when x equals 0. So it's going to be 4 times, to find the constant ratio, I do y2 divided by y1. So 2 divided by 4, that gives me 1/2. So it's 1/2 right here to the power of x. So this is my equation. Okay, next one. My y-intercept is here. So I'm going to have y equals -8 times. I'm going to do y2 divided by y1. So -2 divided by -1/2. That gives me +4. Okay, so let's see. Right here, 4 to the power of x. All right. This one I'm going to give you guys for the exit ticket. And then the last one, remember, so they were nice enough to give us 2 points here. You're going to do the right divided by the left. So -3 divided by -1, which is 3. Okay, that's a constant ratio. Where does it start? What's the y-intercept? Is at -1. So this one is y equals -1 to the power of, parentheses 3 to the power of x. And that's it, guys. All right. Hope y'all learned something. If you have any questions, please let me know. Or Miss Jimenez, you can always email me. And you'll have a good rest of your day. Bye. Oh, make sure you also do the exit ticket. I don't know if I said that. Okay, bye.